The history of the Earth, like human history, can be divided into well-defined periods. The entire history of the Earth is divided in smaller periods as per Geological Time Scale Table 1. The entire period is divided into two main subdivisions, the Precambrian and the Phanerozoic, and the latter is called an eon.
The Precambrian is divided into the Archaean and the Proterozoic eons. Subdivisions of the Phanerozoic Eon are the Paleozoic, Mesozoic, and Cenozoic eras. Further subdivisions called periods of the Paleozoic era are the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian, the Triassic, Jurassic, and Cretaceous of the Mesozoic, and the Paleogene and Neogene of the Cenozoic. Tools for estimating the age of rocks. Fossils. The fossils are remnants of animals that thrived at the time of deposition of rocks in which these are found. The fossils can be in the form of impressions, molds, casts, total cell-by-cell replacement, and rarely in toto. The last example is furnished by mammoths found preserved in Siberia. This mode of preservation happens when all of a sudden the animal is entombed in snow and gets frozen, allowing no time to bacteria to decay the organism. In fact, absence of bacteria is important for any fossil preservation, except the impressions. The animal is buried in the sediments and in course of time it decays, leaving its cast, which is filled by later solutions, mostly containing calcium carbonate, forming its mold fig. 9. Also the solutions over a period of time gradually replace cells of the animal part, thus preserving even its internal structure. Thus the fossils present in the older rocks are of primitive animals and fossils of more advanced animals are found in the younger rocks. Radiometric dating. Radiometric dating is based on the natural decay of radioactive isotopes that are mostly part of trace elements rubidium, samarium, lutetium, rhenium, uranium, thorium, potassium in rock-forming or accessory minerals, e.g. mica, garnet, or zircon. Since the rate of decay of a specific isotope species called the radioactive parent isotope is constant, Hadean 4600 Ma 3800 Ga equals 800 Mi. The initial period of the Earth called Hadean, meaning hellish, was when the Earth was very hot and surrounded by noxious gases. The Earth's surface was originally molten, and as it cooled the volcanoes erupted to release massive amounts of carbon dioxide, steam, ammonia, and methane. There was no oxygen. The steam condensed to form water, which then produced shallow seas. The first DNA was formed during the Hadean.
Archaean 3800 Ma 2500 Ma equals 1300 Mi. With fall in temperature, water vapor condensed to create the first ocean about 3.8 Ga ago. There is evidence to suggest that bacteria flourished 3.8 billion years ago, i.e. the life got underway about 700 million years after the Earth was created. Such early forms of life existed in the shallow oceans close to thermal vents. These vents were also sources of heat and minerals, oxygen released by the evaporation of water and by sea-dwelling microorganisms built up the atmosphere. Around 3.65 Ga ago, oxygen got slowly built up in the oceans and atmosphere. Original oceans were shallow. Proterozoic 2500 Ma 543 Ma equals 1957 Mi. The period from 2.5 Ga to 543 Ma is referred to as the Proterozoic. The Proterozoic witnessed growth of algae and other marine primitive plants at about 2.1 billion years ago. When the concentration of oxygen increased markedly, the ozone layer was formed, which helped to filter out harmful ultraviolet rays, laying foundation for evolution of new organisms in the shallow seas. Colonial growth of algae known as stromatolites, often forming reefs of huge dimensions, grew in shallow seas.
Around 700 million years there was another extensive ice age. Its remnants are found in the Himalaya. The rocks younger than 700 Mi lack pronounced stromatolitic buildups. General absence of algal growth is attributed to lowering of the temperature and also advent of animals that grazed the algal fields. Close to the Proterozoic Cambrian part of the Paleozoic boundary, small-bodied animals appeared. Collectively these are referred to as the Ediacarofauna. Some of these animals were of large dimensions, suggesting absence of predators at that time. Several changes in geographic location of continents have been recorded during the Proterozoic. Paleozoic 543 ma 248 ma equals 295 ma. It comprises the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian.